Hi, my name is Zaixi. Here I want to give you a brief introduction to my work. The highlight of this work is the database that we built. It's unique in terms of the number of videos, the using scenario, and the combination of the distortion types. We built our database and conducted a human subjective quality study where over 12,000 human subjective scores are collected. We then evaluated the state-of-the-art video quality assessment models on the new database. The difference between live streaming and common on-demand streaming is that live streaming suffers from already distorted sequences. Because there's no opportunity for post-production, more complicated and frequent distortions may occur in live streaming. The high-motion nature of sports video also add more challenge. High-motion contents are in general harder to compress, and they can introduce artifacts easily. Also, temporal distortions, which is more common in live streaming case, can have a more salient effect on sports content than generic contents. For example, Judder videos, which is a type of distortion, may have a more jerkiness effect on the motion of a player or a motion of the ball. Most of the existing databases lack the focus of temporal distortions, and they only include compression or scaling artifacts. No existing database contains such a rich variety of distortion types as our database. Moreover, our database contains 45 pristine stored sequences. That is a lot more than previous works. In this slide, we summarize the 6 distortion types that we include in our database, and they are the most common ones in live streaming. We use the H.264 for compression because it's the most common codec used in live streaming. It's worth notice that judder is a temporal distortion. It creates a motion jerkiness, which is very uncomfortable in high motion videos. We simulate flicker by alternating the QP value in H.264 codec. For frame drop, when that happens, we'll simply repeat the previous frames. Nowadays, there are still a lot of live streaming videos captured in interlacing format. When they are deinterlaced improperly, they can create a cobbing effect. We conducted a human subjective quality study and acquired the most score on each videos. Here we present some analysis of the human subjective scores. From the figure on the top, we notice that different distortions result in very different distribution of the mean opinion scores. We also notice that for different resolution, usually the distribution of the most score are different, especially when they have spatial distortions. However, for temporal distortion types, it's less obvious. For those distortions that have multiple levels, it's noticed that there's some overlap between different distortion levels. This is due to the interaction of the content and the distortion. We performed an objective quality study where all the SOTA VK models are compared. Overall, GPQA is the best, and some VK models only consider the spatial information, and they don't have very well performance on temporal distortions. In conclusion, we created a large-scale video quality database targeting high-motion live streaming scenarios. The new resource includes 45 different contents and 6 different distortion types. The new database will be made publicly available.